in this example, we're looking at the function f of x equals x squared minus 5x plus 1. And I have actually graphed it in Desmos and then labeled a few points on it. So we are going to find the average and the net change on given intervals. So given the points that I've got labeled here, we'll look at the interval from -1 to 1. We'll look at the interval from 1 to 3. And we'll look at the interval from -1 to 5. Now, I have 4 points labeled, so you could also look at others too. These are just 3 intervals that I'm looking at for the sake of having 3 examples in this lesson. All right, so the interval from -1 to 1. So remember, going back to our previous lesson, we are looking at the net change is simply the change in the values of the function. So in my previous lesson, I used the blue highlighter to show that. So here is the point -1,7. So the y coordinate is 7, the x coordinate is -1, and here is the point at 1, -3. So the x coordinate is 1, the y coordinate is -3. So this is an important moment. We haven't seen this before. Notice that the function ends up lower than where it started. So in the examples that we looked at with the home sales, both situations, our homeowners were very lucky because they were able to sell the home for more money than what they bought it. So we could talk about how much they made money, what rate they made money at, but the bottom line was they walked away with money because they sold for more than they bought. That is absolutely not a guarantee. You can absolutely end up with less than what you started. It happens with lots of things. In fact, real estate in California is one of the rare examples of buying something where you can actually sell it for more than you bought it for later. Almost every other thing loses value over time. Cars, clothes, tools, all of those things lose their value as time passes. And that's what happens here. At the start of this interval, the value of the function is 7. And then as x moves from -1 over to 1, the value of the function falls from 7 down to -3. So the net change is actually negative. And the way that we would write that here is we would say the net change was -3 minus 7, which is -10. If you wanted to say it in words that make a little bit more sense, you would say the value of this function fell 10 units between the inputs -1 and 1. If the net change is negative, the average rate of change is going to be negative also. So average rate of change well, I think I messed up my color coding, but that's okay. So if we connect these 2 points, okay, let me do a slightly better job drawing this line. There, it's not great, but good enough. So the slope of this line, and I'll highlight it also, but I've got the colors of my highlighter backwards. So this here, The slope of that line is the average rate of change. And so, again, we know it's going to be negative because the net change was negative. But what we have here is negative 3 minus 7 over 1 minus negative 1. So that's negative 10 over 2. So that's negative 5. Okay? Now, I always personally find it to be more intuitive to kind of talk about this in terms of the holistic picture. The value of this function fell from 7 down to negative 3. So the value fell 10 units. How long did it take to fall that far? Well, it started at 7 when x was negative 1, and it fell down to negative 3 by the time x changed to 1. So x moved 2 over, right, from negative 1 to 1. That's 2 steps, and y fell 10 units. So there's 10 negative units of change in the y direction for 2 units of change in the x direction, okay? So that's the first example. Now let's look from 1 to 3, okay? So same thing, we're going to look at net and we're going to look at average. So the net, you're just looking at the change in the value. So again, you can see that you have a downward, you have a decrease. So we started with a y coordinate of negative 3, and we ended with a y coordinate of negative 5. So it's smaller, but we still have a decrease. So this is our net change for the second example. So we look at the value at 3 and subtract the value at 1. So this net change is negative 2. So again, the value of the function fell between 1 and 3. But if you compare, right, talking now about average rate of change, yes, the value fell in both cases, but if you compare how quickly it fell, you'll notice that in the second problem, the descent is a lot less steep, right? So if I draw in this line connecting these 2 points, it's still a line with a negative slope. Like, nobody is arguing with that. There is that line. It still absolutely has a negative slope. But it's a lot less steep, okay? So in terms of finding the average rate, we're going to look at negative 5 minus negative 3 minus divided by 3 minus 1. So once again, x is changing by 2 units. It's going from 1 to 3. But y is only falling by 2 units. So it's a significantly slower rate of decline, right? Whereas in the first example, we were going down on average 5 vertical steps per horizontal step. Here we're only going down 1 by 1, okay? So the last example in this particular lesson, I want to look at the interval from negative 1 to 5. But then as we're getting ready to move on from this lesson, I'll give you some examples of things that you might want to consider, okay? So from negative 1 to 5, well, still a decline, okay? I wanted to focus this particular lesson on functions that decline on given intervals. So at negative 1, you're up and you're at 7. 5, you're at 1, okay? So if you're looking at the change in the output, there it is it is from 7 down to 1. And clearly you can see that this is a decline by 6 units. So the net change here, the value of the function was 7 at -1, and it's down to 1 by the time that x is 5. So the net change is -6, okay? Because again, you're comparing where you ended up with to where you started. And now average rate of change. Okay, so same thing. We take these 2 points at -1, 7 and at 5, 1, and we connect them. And we look at the slope of this line. So sure enough, you can see that it's a line with a negative slope. It's trending downward, but it's not trending down as steeply as it was from -1 to 1. In fact, if you pay real close attention to making a really good picture, you might even notice that these 2 lines, this one and this one, they're parallel, right? So if you remember a little bit about your lines, you'll remember that 2 lines are parallel if they have the same slope. So sure enough, if we look at the average rate of change over the interval from -1 to 5, we have the net change, which is 1 minus 7 over the x-coordinates, which is 5 minus -1. So we have -6 over 6, which is -1. So we actually have the same average rate of change in example C as we did in example B, even though we have very different net changes, okay? So if the slopes of the lines connecting the beginning and the end are the same, so if those 2 lines are parallel, you will absolutely have the same average rate of change, even if your net changes were different. So this was an example focusing on declines. So I specifically picked intervals where you would have a negative change. So I want to finish by saying one last thing, which is that a function is called increasing on an interval if both net and average rate of change are greater than 0. And a function is called decreasing on an interval if both net and average rate of change are negative. So over all 3 of these examples, this function is decreasing. Now, if you're sitting here thinking, so does that mean that this function is just always decreasing? No, we have just talked about these 3 intervals. So if you're curious, so for more practice, look at the net and average rate of change, and you'll notice I start abbreviating average rate of change as ARC on the interval from 1 to 5. Okay? So already just looking at what we have here, you might be able to tell, oh look, sure, it's gone up from 1 to 5. So that's an example of an interval in the domain of this function where the net and the average rate of change will be positive, so the function is increasing. But I'll let you all practice that on your own to see it. That's it for this lesson. In our next lesson, we're actually going to introduce something called an arbitrary interval, where rather than specifying the beginning and the end points, we allow them to be whatever we want, flexible. See you in your next lesson. Bye.